Polaris, designated Alpha Ursae Minoris, commonly the North Star or Pole Star, is the brightest star in the constellation of Ursa Minor. It is very close to the north celestial pole, making it the current northern pole star. The revised Hipparcos parallax gives a distance to Polaris of about 433 light-years, while calculations by other methods derive distances around 30%. Closer.Polaris is a multiple star, comprising the main star in orbit with a smaller companion, the pair in orbit with Alpha UMi B. There were once thought to be two more distant components, Alpha UMi C and Alpha UMi D, but these have been shown not to be physically associated with the Polaris system. Stellar system. Alpha UMi A is a 4.5 solar mass F7 yellow supergiant. This is the first classical Cepheid to have a dynamical mass determined from its orbit. The two smaller companions are Alpha UMi B A 1.39 m F3 main sequence star orbiting at a distance of 2,400 astronomical units, and Alpha UMi AB, a very close F6 main sequence star with an 18.8 astronomical units radius orbit and 1.26 m. Polaris B can be seen even with a modest telescope. William Herschel discovered the star in 1780 while using a hand-built reflecting telescope, one of the most powerful telescopes at the time. In 1929, it was discovered, by examining the spectrum of Polaris A, that it was a very close binary, with the secondary being a dwarf, which had been theorized in earlier observations. In January 2006, NASA released images from the Hubble telescope that showed the three members of the Polaris ternary system. The nearest dwarf star is in an orbit of only 18.5 astronomical units, which explains why its light is swamped by its close and much brighter companion, variable star. Polaris A, the supergiant primary component, is a low-amplitude population I classical Cepheid variable, although it was once thought to be a Type II Cepheid due to its high galactic latitude. Cepheids constitute an important standard candle for determining distance, so Polaris, as the closest such star, is heavily studied. The variability of Polaris had been suspected since 1852. This variation was confirmed by Ejner-Hertzsprung in 1911. The range of brightness of Polaris during its pulsations is given as 1.86 to 2.13, but the amplitude has changed since discovery. Prior to 1963, the amplitude was over 0.1 magnitude and was very gradually decreasing. After 1966, it very rapidly decreased until it was less than 0.05 magnitude. Since then, it has erratically varied near that range. It has been reported that the amplitude is now increasing again, a reversal not seen in any other Cepheid. The period, roughly 4 days, has also changed over time. It has steadily increased by around 4.5 seconds per year, except for a hiatus in 1963 to 1965. This was originally thought to be due to secular redwood evolution across the Cepheid instability strip, but it may be due to interference between the primary and the first overtone pulsation modes. Authors disagree on whether Polaris is a fundamental of first overtone pulsator and on whether it is crossing the instability strip for the first time or not. The temperature of Polaris varies by only a small amount during its pulsations, but the amount of this variation is variable and unpredictable. The erratic changes of temperature and the amplitude of temperature changes during each cycle, from less than 50 K to at least 170 K, may be related to the orbit with Polaris AB. Research reported in Science suggests that Polaris is 2.5 times brighter today than when Ptolemy observed it, changing from third to second magnitude. Astronomer Edward Ginnern considers this to be a remarkable change and is on record as saying that, if they are real, these changes are 100 times larger than predicted by current theories of stellar evolution. Names. Because of its importance in celestial navigation, Polaris is known by numerous names. It became known as Polaris during the Renaissance. Its name derived from the Latin polaris, of near the pole. In 2016, the International Astronomical Union organized a working group on star names to catalogue and standardize proper names for stars. The WGSN's first bulletin of July 2016 included a table of the first two batches of names approved by the WGSN, which included Polaris for this star. It is now so entered in the RU catalogue of star names. One ancient name for Polaris was Cynosura, from the Greek kappa upsilon nu omicron sigma omicron upsilon rho alpha, the dog's tail, hence the English word cynosure. Most other names are directly tied to its role as pole star. In English, it was known as pole star or north star. In Spencer, also steadfast star. An older English name, attested since the 14th century, is lodestar, guiding star, cognate with the Old Norse Lithastjana, Middle High German Leitstern. Use of the name Polaris in English dates to the 17th century. It is an ellipsis from the Latin stella polaris, pole star. Another Latin name is Stella Maris, sea star, which, from an early time, was also used as a title of the Blessed Virgin Mary, popularized in the hymn Avenue Maris Stella. In traditional Indian astronomy, its name in Sanskrit is Dhruva Tara, fixed star. Its name in medieval Islamic astronomy was variously reported as Mismar, needle, nail, al-Kutb al-Shamali, the northern axle, spindle, and al-Kawkab al-Shamali, north star. The name al-Rukaba, a Rukaba that was reported in 16th century Western sources, was that of the constellation. In the Old English rune poem, the T rune is identified with Tyr, fame, honor, which is compared to the pole star with Tacna sum. Yieldeth tree well, is a sign it keeps faith well. Shakespeare's Sonnet 116 is an example of the symbolism of the North Star as a guiding principle. Is the star to every wandering bark, whose worth's unknown, although his height be taken. Quote, in Julius Caesar, he has Caesar explain his refusal to grant a pardon by saying, I am as constant as the northern star, of whose true fixed and resting quality there is no fellow in the firmament. The skies are painted with unnumbered sparks, they are all fire and every one doth shine, but there's but one in all doth hold his place, so in the world. Of course, Polaris will not constantly remain as the North Star due to precession, but this is only noticeable over centuries. In Inuit astronomy, Polaris is known as Nikurtsutak. It is depicted on the flag and coat of arms of the Canadian Inuit Territory of Nunavut, as well as on the flag of the U.S. state of Alaska. Role as pole star. Because Alpha UMi lies nearly in a direct line with the axis of the Earth's rotation above the North Pole, the North Celestial Pole, Polaris stands almost motionless in the sky, and all the stars of the northern sky appear to rotate around it. Therefore, it makes an excellent fixed point from which to draw measurements for celestial navigation and for astrometry. The moving of Polaris towards and, in the future, away from the celestial pole is due to the precession of the equinoxes. The celestial pole will move away from Alpha UMi after the 21st century, passing close by Gamma Cephei by about the 41st century. Historically, the celestial pole was close to Thuban around 2750 BCE, and during classical antiquity it was closer to Tab than to Alpha Umi. It was about the same angular distance from Beta Umi to Alpha Umi by the end of late antiquity. The Greek navigator Pytheas in California, 320 BCE, described the celestial pole as devoid of stars. However, as one of the brightest stars close to the celestial pole, Polaris was used for navigation at least from late antiquity, and described as epsilon iota phi alpha nu eta sigma, always visible by *The. Alpha Umi could reasonably be described as stellar Polaris from about the High Middle Ages. In more recent history, it was referenced in Nathaniel Bowditch's 1802 book, American Practical Navigator, where it is listed as one of the navigational stars. At present, Polaris is 0.75 degrees away from the pole of rotation and hence revolves around the pole in a small circle 1.5 degrees in diameter. Only twice during every sidereal day does Polaris accurately define the true north azimuth. The rest of the time, it is slightly displaced eastward or westward, and the bearing must be corrected using tables or a rough rule of thumb. The best approximate was made using the leading edge of the Big Dipper asterism in the constellation Ursa Major as a point of reference. The leading edge was referenced to a clock face, and the true azimuth of Polaris worked out for different latitudes. Distance. Many recent papers calculate the distance to Polaris at about 433 light-years, in agreement with parallax measurements from the Hipparcos astrometry satellite. Older distance estimates were often slightly less, and recent research based on high-resolution spectral analysis suggests it may be up to 100 light-years closer. Polaris is the closest certified variable to Earth, so its physical parameters are of critical importance to the whole astronomical distance scale. It is also the only one with a dynamically measured mass. The Hipparcos spacecraft used stellar parallax to take measurements from 1989 and 1993 with the accuracy of 0.97 milliseconds, and it obtained accurate measurements for stellar distances up to 1000% away. The Hipparcos data was examined again with more advanced error correction and statistical techniques. Despite the advantages of Hipparcos astrometry, the uncertainty in its Polaris data has been pointed out, and some researchers have questioned the accuracy of Hipparcos when measuring binary fields like Polaris. The Hipparcos reduction specifically for Polaris has been re-examined and reaffirmed, but there is still not widespread agreement about the distance. The next major step in high-precision parallax measurements will come from Gaia, a space astrometry mission launched in 2013 and intended to measure stellar parallax to within 25 microarcseconds. Gaia will not be able to take measurements on bright stars like Polaris, but it may help with measurements of other members of assumed associations and with the general galactic distance scale. Radio telescopes have also been used to produce accurate parallax measurements at large distances, but these require a compact radio source in close association with the star, which is typically only the case for cool supergiants with mazes in the circumstellar material. History of observations.